at dothemath@kern.org. You can watch the show online at dothemathonline.net. And we're on social media. Look for us on Facebook and Instagram, Twitter, and YouTube.
All right. Well, we do have a lot of things going on today. I know that we have a guest coming in studio in just a few moments, so they'll be here to help us out do some math. As Mary Lou said, we're at Castle Elementary today, and there are some exciting things going on at Castle Elementary. STEAM is about to roll into Castle Elementary for next year. A lot of students are familiar with STEM, the science, technology, engineering, and math.
Right.
But STEAM is adding the arts into that as well.
That's neat.
And by the help of Chevron and some others, Castle is one of the schools that is, I guess, on the forefront of this, or going to implement quite a bit of this next school year. So maybe Mary Lou will be able to hook up with somebody out there today, aside from doing math projects, and find out a little bit more about that STEAM out there. But before we get to that and the phone calls of the afternoon, let's first take a look at today's Math in the News. So glancing at news items on the internet the other day, there was one came up and said, can you solve this math problem or whatever percent of adults can't solve this problem, right? So obviously I had to click on it and see what was going on.
Why not?
All right, and I guess it's been going around and people are posting it on Facebook or whatever.
And it's always surprising how big a percentage of people who
right, it's like 70%, of adults can't pass this or whatever. But anyway, let's go ahead and take a look at it. And we'll let the students at home and the adults that are watching as well take a look at this also, in case you haven't seen it. So we've got an apple plus an apple plus an apple is equal to 30. Then an apple plus some bananas and more bananas is equal to 18. Apples take away coconuts.
Bananas.
Yeah. Bananas take away coconuts is equal to 2. A coconut, an apple, and some bananas is equal to something, which is what we need to figure out.
Right.
So, taking a look at this, Jesus, the first line, we know that 3 of the same things will equal 30.
Agreed.
So, because there are a lot of times young students, primary age students, will be getting problems like this. And they're like, well, I see 3 apples, it should just be 3. Okay, but we know it's going to be 30. So what's one way of attacking this?
Well, I think that it's 3 apples, or 3a if you want to think of it in those terms as a variable, is equal to 30. So I'm thinking 3 times some variable is going to give me a quantity of 30.
Right, and even if students are just going, all right, well, I know I can add 3 of the same thing to get 30,
right.
and I know I count by tens, 10, 20, 30. So I could therefore say that an apple is worth
one
10.
Individual apple is 10.
Is 10. So let's say go ahead and take a look at the next one. We've got an apple and we've got some bananas, but more bananas. So we can't say that bananas are 8.
No.
Right.
Because then it would only be 1 set of bananas. But we have 2 sets of bananas.
Right.
So instead of bananas being 8, we could then infer that bananas are 4, because we know that there's going to be 2 of them that are going to make up 8. So we can see that each of those bunches of bananas will be worth 4. So therefore, we take the 4 that we know the bananas is and take away the coconuts, and we know we end up with 2. So knowing what our end result is, we know that the coconuts must be worth a value of 2. So this is where the adults get it wrong. Okay, the last one. So what they're saying is they say coconut and apple and bananas is equal to 16.
No, wait a minute. I don't know what that symbol is down there on the bottom for that one coconut. That's different than the one above it.
See, so if you're saying that this one coconut is different than the 2 coconuts, that's the key. So we know that 2 coconuts is 2. And most of the adults that look at this go, the bottom answer is 16, because they're assuming that the coconuts is 2, the apple is 10, and the bananas are 4.
And coconuts is coconuts, right?
But coconut, right? So that's why they're saying it's 16, and then you've got all this wild percentage of people that get it wrong. The answer is actually 14, because the 1 coconut is worth 1.
Yeah.
Well, no, because we're going to go 4 minus 2. The apple is 10.
Yeah.
Now, the bunch of bananas was what? 4.
It was 4. So
but that's not the same bunch of bananas. There are fewer bananas.
So, I'm sorry.
There's half as many bananas as that is what they're saying.
Really? You
Right.
mean I see 3 bananas in the first one, 3 bananas in the second one. Are there...
And I guess what they're saying is there are more bananas, so there's one back there. So they're saying that there's more in that bunch of bananas than down in this bunch of bananas.
I think it's just the...
So they're saying this is half the amount of that, just like the coconut is half the amount of that.
I think you're taking some artistic license there,
Well,
because I think that
what I'm
bunches
saying
of
is this is
bananas
one
are
of
the
those
same.
things that is floating around out there, which is why 70, 80, 90% of the adults are missing this problem. But anyway, that is today's Math in the News.
Wait a minute. So
Using the apples, bananas, and coconuts.
what was the answer?
Well, look, so we've got...
14, huh?
So here we've got the 4 minus 2 is 2,
Yeah.
right? Right. So that's what we've got.
So how do we know there's 6 bananas and
Well,
maybe 4
perhaps when
bananas?
you draw up one, and you can use some different fruits or whatever you like in there, maybe some bakery products, and
okay.
get donut holes, how many are there, as opposed to donuts, if they're glazed, iced, whatever. Anyway, once again, we will move on. We do have phone tutors available until 5:30, Tuesdays and Wednesdays throughout most of the school year. Right now, before we go live out to Castle, we're going to have Chuck work on something that a lot of students in upper elementary and junior high are working on.
Yes.
So here's the problem that we're going to have you work out 2 different
Okay.
ways. So we have what is 85% of 62?
So I noticed on one of our shows, on one of the live feeds, that Mary Lou was doing some percent problems with the students. And so, depending on what grade you're in, you'll do this problem different ways. Sometimes they do it using pictures. They'll use models. They'll use diagrams. But a lot of times, once they get into solving problems, they'll do a problem like this using a proportion. And very often, now whether the book or the teacher uses these exact same words, but very often they'll do a problem with a proportion, and they'll take the 4 numbers that are involved in a percent problem. And we always know that in a percent problem, there's always a percent, and because there's a percent, that means out of 100. And then when we look at the problem, very often, depending on how it's written, we'll have an is number, right? In this case, it's what is. And we'll have some total of 62, so we have an of number. So very often they'll do a problem like this using the is over of, the is number over the of number equals the percent over 100. So if I do this problem using a proportion, I can do this as is, well, let's see, is what we're looking for, so I don't know what that is. Of, I do know what it is, and the percent's always very easy to find. So the is number is what I'm looking for. I'll call it n for the number. The of number is 62. The percent was easy. That's 85. And percent's always based on 100. So an easy way to set up this problem is to set it up as a proportion. And then we can cross multiply. We know in a proportion, equal fractions, the numerator times the other denominator equals the denominator times the other numerator. So we know that 100n is going to equal 62 times 85.
It's 5,270.
5,270. And then, so the question is, what number times 100 equals 5,270? And we can figure that out by dividing, or if you do a very simple equation, all we have to do is divide by 100. And if I divide that by 100, again, if they've worked with decimals, they can say that anytime you divide by 100, you just move the decimal point 2 places. So 52.70 or 52 and 70 hundredths, or just 52 and 7/10, right? We can drop off that 0. So that's one way of doing that problem. Very straightforward and very nice to use that proportion. Okay. Now, once you get into algebra and you want to just solve an equation, we solved a very, very simple equation just dividing by 100. We can do this problem slightly different by taking what is 85% of 62. I'm going to rewrite it because I'm going to translate this from a sentence into an equation. And the important thing to know is these two words. What do the is and the of stand for? Well, in an equation, what is, the is the equal sign. And the of is a multiplication sign. So the other way of doing this problem is what, that's n, is, now 85%, we know that 85%, we said that percent means out of 100. I can write it as a fraction, but I can also write it as a decimal because I know that 85 hundredths is 2 decimal places. It's 0.85 times 62. Let's see if I can get rid of this. Nope, I guess not.
Almost got it.
Almost had it. So I know that I can just multiply 0.85 or 85 hundredths times 62. Well, I know that 85 times 62 that I did down here is 5,270. And since I'm multiplying with a decimal, I've got 2 decimal places. So my answer is still 52.70.
All right, nicely done. With
basically the same question, just as an equation instead of a proportion.
All right. Hey, we do have phone tutors available until 5:30. Do remember, if you're calling from San Luis Obispo County and we do one of your math problems on air, you'll automatically receive yourself some ice cream courtesy of Doc Bernstein's Ice Cream Lab. Right now, we'll go out to Castle Elementary and Mary Lou.
We are live today at Castle Elementary School, ACES After School program, and I have a special guest with me today, Mark. How you doing, Mark?
Good.
Can you tell everybody what grade you're in?
Fourth.
Fourth grade. Okay, so Mark and I have been having some fun, huh?
Uh-huh.
I already know what he really likes to do. He likes to dance, all right? Mark, can you show everybody how you've been showing me how to do the Running Man? Go for it. There is no way I'm going to try that. You do it so well. All right, so in fourth grade, you're working on fractions.
Yeah.
Yes?
Yeah.
Okay, so I got a problem for you. All right, maybe you could dance your way through this problem.
Okay.
Okay, here we go. So we have 3/8, everybody. Everybody around us has paper and pencil. They're going to try this too, huh? 3/8 plus 5/16. Now, Mark, can you tell us how we need to solve this problem?
We need to solve it by turning this into a 16.
Okay, do that for me. You could do it down here.
And 8 times 2 to make 16.
Okay, so now we're going to rewrite it this way, okay? Because you said you like to solve it this way, right?
Yeah.
Okay, so now we changed the 8 to a 16, so let's put that down there.
16.
Okay, and are we going to keep the 3 mark, or are we going to change that?
Gonna keep the 3.
You sure? If we have 8 times 2 is 16, what do we need to change and multiply the 3 by? Do we also need to multiply it by 2?
Yeah.
Okay, we want to multiply it by 2, don't we? Yes?
Mm-hmm.
So it's 3 times 2.
6.
Okay. What did we just do, Mark? Did we just make an equivalent fraction?
Yes.
Yeah, we did, right? And when we're adding fractions, do our denominators have to be exactly the same?
Yes.
Yeah. Okay, so what are we going to do with 5/16?
We're gonna,
We're going to keep it?
yeah.
Okay.
16.
Okay, now our denominator's the same.
Mm-hmm.
Okay, so what do you have to do to solve that?
Add it.
Add it. Go for it.
So that's 11 divided by...
Okay, do we need to simplify that at all?
No.
No, that's already simplified, huh?
Mm-hmm.
So we have to make sure that our denominators are exactly the
Same.
All right, Mark, we got 4 groups out here working, huh?
Yeah.
All right, pick a group. Let's find out what they did. Okay, go ahead. Go for it. Let's walk over to this group to see how they did. How we doing over here, guys?
Good.
Good. Okay, can you kind of show us how to solve that problem? How would you guys solve it?
So we put down the 3
Okay.
and then and then we add. Wait, we times them.
Right. We're going to times the 3 by what?
By 2.
Okay.
And then we're gonna.
What's 3 times 2?
6.
Very good. And what did Mark change the 8 to? Did you change the 8 to
16?
Yeah, to 16. There you go. Now we got to add the 5/16 to that, don't we?
Yes.
Okay, show me how to do that. Let's add our 5/16 to that. There you go. And what's 6 plus 5?
6 plus 5 is 30.
No, that's 6. That's 6 times 5 is 30. Good job on that, but we're plussing. So it's 6 plus. You could group help them out. What's 6 plus 5?
11.
Is what?
11.
11. There you go. 11 over 16. Good job, you guys. Okay, so are all the groups ready? We got another problem for you. Okay? All right, Mark, you get to pick the numbers. Ready? Okay. So, here we go. Write a number up there. You guys, the recorders are ready? Let's write this down. 2. Okay, put another number there. Over 10.
6.
There you guys go. Go. Let's go see what they're doing, okay? Come on. Let's see how they're talking out. Let's go right here. What do you guys think you guys have to do first?
We think we gotta multiply by 2.
Okay, go for it.
20. Yeah, okay.
Okay. So what are we going to change this to?
2 20ths.
Is it 2 20ths, or since you multiply the 10 by 2, are we going to multiply the 2 by 2 as well? Okay, what's 2 times 2?
4
So it's going to be 4 over.
over 20.
There you go. So let's write 4 over 20. And I'm going to let you guys keep working. Okay, how we doing over here, guys?
Good.
You already have it? You have it? Oh my goodness, let's see. Okay, somebody tell me what you guys did.
Okay.
Okay, go ahead.
We did 2 10s and we times it by 2 so it can give us 420.
Okay.
And then we added 4 20ths plus 6 20ths and we got 10 20ths.
Can 10 over 20 be simplified?
Yeah. Yes.
What can I divide both 10 and 20 by? What do you think?
4
Oh, yes, 2, but is there a bigger number?
4 times 5
Okay. What?
by 10.
By 10. So what is, you got a pen, ready? What's 10 divided by 10, everybody?
1.
Write it up here. 1, you got that right. What is 20 divided by 10?
2. Wait.
2, yeah, write 1. Let's write 1. And then, what is 20 divided by 10?
2.
2. Underneath that 1, put your fraction bar. And put your 2. Okay, somebody write 1 over 2 for me.
Okay.
Write 1 over 2. So we have, there you go. So 10 over 20 is what?
1 over 2.
1 over 2. Real quick, you guys, let's go ahead and wrap it up. Remember, when we are adding with fractions, we have to change the denominators to the what? To the same?
Number.
Yes?
The same number.
To the same number. Good job, good job. And when we come back, we'll probably be working on subtracting fractions. All right, back to you at the studio.
All right, nicely done with that, Mary Lou, out at Castle Elementary. Hey, we do have phone tutors available until 5:30. As promised, in studio with us right now, we have Gabriel. How are you?
Hello.
Why don't you let everybody know where you go to school and what grade you're in?
I go to school in Singlum and
What grade are you in?
5th grade.
5th grade. Yeah, don't worry about the different cameras. We'll just chat and stuff like that.
All right.
How's 5th grade going?
Pretty well. I'm doing pretty good in school.
Well, that's good. You been to Singlum for a while?
I started going there at the beginning of 3rd grade.
Okay, so you're getting used to the school and things like that. And they've done some remodeling out there, right?
Yeah.
So you like what they've done with the place?
Oh yeah, they still have a big area to cover.
Well, they've still got a little bit of time, I think, to go, right? And I think they're getting it all ready for next school year.
Yeah, they have they had this whole back place where they had a playground and a ton of classrooms, and they still have that whole place to destroy and rebuild. So there's probably going to be more stuff in the near future.
Good. Well, you know what? We're going to have you get to work in a little bit, but right now we're going to have Jesus go over a little something as far as taking a look at answers and reasonableness of them.
Right. I call this just justifying your answer, and I think it's an important strategy for all students to have. I think Chuck did a great job showing us how to come up with the answer. He showed us two methods, using a proportion and also solving algebraically. And we have our answer here. So the original problem that he started with was, what is 85% of 62? And our answer showing was 52.7. Now, when I do a problem like this, I always want my students to just be certain of their answers. So what we like to do is look at this and say to ourselves, how can we check to just make sure our answer is reasonable? So we're not just mindlessly putting an answer down and just going with it. We want to always make sure we have our answer. And the method that I want to show you is an important method just for, when you're at the store or when you're at a restaurant or anything, you'll want to know how to find a percentage. 10% is the easiest to find. And if you find 10% of a number, it's just a matter of multiplying something. So what I'm going to do is just kind of take you back through this and just ask myself, did Chuck do this problem right? Or is his answer fairly close to what it should be? And what I'll do is just look at the original problem and say, okay, 85% is what I want to find of 62. So what is 85% of 62? Well, without actually doing any kind of multiplication or anything, I'm going to try some mental math, but I'll write it on the board so you can see what I'm thinking. I'm thinking, first of all, what is 10% of 62? That's a good question. Well, if I'm going to do this mentally, I'm just going to make this 60, so it's a number I know. So in my mind, I'm thinking, well, what is 10% of 60? Now, 10% of a number is really easy because in our base 10 system, all we really do is say, move the decimal one time. So really, 10% of a number is just a decimal shift, and now I know that 10% of 60 is 6. That's great. I know that if I can find 10% of a number, it's now just a matter of saying, well, what if I want to find 80%? 8 times 6, in my mind I'm thinking, I know that that's 48. And if I wanted to go, well, 90%. What's 90% of 62? Well, 9 times 6 is 54. So in my mind, of course I'm not doing this on a piece of paper or anything, but in my mind I'm thinking to myself, I know that my answer must be somewhere in between these two values, and Chuck got the answer 52.7. So is his answer reasonable? Does his answer make sense? So if I was punching numbers on a calculator at home doing my homework when I shouldn't have been using a calculator, I'm thinking to myself, at least I know that this answer is fairly reasonable. Now I think that's important for you, especially when you guys go to restaurants. As you get older, boys, if you ever go to a restaurant and you're out on a date, giving a tip is typically 10 to 15%, maybe 20% if it was a great meal. It's important for you to have a basic way of knowing 10%, 20% of a number. So think about what it might be for the next time you're at a restaurant with your family. Look at the total and then see if you can calculate 15% or 20% of that so you can find out the tip using a quick mental math strategy like I just showed.
There you go. Great point, Jesus. Why don't you erase the board? And we'll, you know what? We'll leave you right up there, young man. Okay. So erase the board and we'll send Gabriel over. You guys are going to work on simplifying an expression. Because this is something he's been working on and has a little bit of, I want to make sure I'm doing it right. So Gabriel, why don't you head on over to the board? Jesus, I'll let you go ahead and write this.
Okay,
we'll start over on the left-hand side. We've got 2. And let's open a bracket.
All right. Well, parentheses is fine. Okay.
8 plus, and then open another parenthesis.
Okay.
5 minus 3. Close that set of parentheses. Close the other set.
And I'll go ahead and make a bracket.
Minus
I see what
8.
You're doing
Yeah,
here.
there you go.
My apologies.
And then minus 8 after the other bracket.
Minus 8.
All right, Gabriel.
Okay.
How do you think you'd go about solving this problem?
So before we actually do anything, let's just talk about some strategies here. When you see these brackets and you see these parentheses, they're really the same thing, aren't they? They're saying focus on this stuff, right? So which one should I attempt doing first?
The brackets?
These are definitely the brackets here, and I agree. We're definitely going to put our attention in this area here. I'm not worried about the minus 8 or the 2. I'm definitely going to look inside the brackets. But with the rules with parentheses and brackets, they're really the same thing, is always go to the innermost piece.
Okay.
And so now we have that, and you see it's a 5 minus 3. So in your mind, 5 minus 3, go ahead and give me that answer really quickly.
2.
And so once we have this result, we're now going to just kind of slowly work our way outside to the next set of brackets. 8 plus this answer, aren't we?
Oh, okay.
Okay, so I'm going to let you attack this piece first, and then we'll kind of rewrite it.
All right. So 2 that equals 2, and then we bring the 8 down.
Sure. I always rewrite the problem.
And then plus, and then it equals 10.
Okay, so now let's go ahead and just write our answer. With this bracket here, let's go ahead and use the square bracket. So go ahead and make an open bracket. Put your new answer 10.
A bracket or a parenthesis?
So let's go ahead and put a bracket. Yeah, we can.
Bracket.
The parentheses and brackets are the same thing, so we can use them interchangeably. Go ahead and put your 10 in there.
10.
And let's go ahead and close our bracket, right? Because the whole answer here is 10. Now, what do you notice right here in front? That's a 2. What are we saying when we see a 2 in front of a parentheses or 2 in front of brackets? Do you know what type of mathematics that is that we're asking for?
It's.
Give you a hint.
Oh, multiplication.
Right. So whenever we see a number like 2 in front of a parentheses or a bracket, we know we're going to have to multiply. So what we're saying is 2 times this quantity.
Oh, okay.
All right. So let's go ahead and put 2 in front of that bracket right there.
2.
And we'll put the symbol just to help us. All right. And let's go ahead and bring down this -8 so we have it as well.
-8.
Okay. Now, order of operations. This is back a couple years, right? Please
Yeah.
excuse my dear Aunt Sally. Which one do we do first? Multiply or subtract?
We you multiply.
Multiply. Okay, so I have this problem right here that says 2 times 10.
Yes.
So go ahead and give me the answer to 2 times 10, and we'll write it down below.
20.
And we'll go ahead and copy down this -8.
-8.
Now, without taking your shoes off, go ahead and give me the answer to that.
12.
All right, good job. And so we have this problem right here, and we're not solving for x, or we're not trying to, there's no equal sign. So what we're doing is we're just combining all of these to make it look a little bit more clear, and we call that simplifying, or simplifying this expression. So our answer, of course, is 12.
It's that easy?
It's that easy, man. Good job.
I don't remember it being
See that,
easy.
Gabriel? That easy, right? It's just continuous practice and doing some problems and things like that. Hey, we do have phone tutors available until 5:30. 636-4357 is that phone number. We'll be back with more right after this. We're on the Central Coast. We're at Templeton Middle School, home of the Eagles, and today we're here to... Templeton Middle School is where we're at. All right, you know what? We're going to go with this, Merrick. You're an 8th grade student here at Templeton Middle School. You ready to go?
Yeah.
All right, we're going to compare some fractions. So what's the first set that we have right here?
Okay, so we have 5, 6, and 3/4.
All right, so we need to know if the one is greater than, less than, or equal to. So how do you go about doing this?
So you could do it in one of 2 ways. You could either make the denominator the same, or you could turn it into a decimal. But I'm going to make the denominator the same because I think it's easier.
All right.
So you have to find the lowest number that they both go into.
Right.
And 6 goes into 12 and 4 goes into 12.
All right, so you're going to turn them into 12s?
Yes.
Okay.
And 6 goes into 12 2 times. So that's times 2. And then that's 12. So then you have to do the same thing to the top, times 2. And that's 10.
All right.
So that's 10 12s. And then this one, 4 goes into 12 3 times. So times 3, you get 12. And then you do the same thing to the top, times 3, and you get 9. And you can see that 10 12ths is greater than 9 12ths. So 5 6 is greater than 3/4.
Nicely done. All right. How would you like to do this one? Because you said there's a couple of different ways you could do it. You said one was turn them into decimals. You could do that. You could get common denominators. We've done that. Is there another way that you could do this?
I just use those 2 ways.
Okay,
but
because these right now are improper fractions, right? Because the
Yeah.
numerator is a little heavier than the denominator. So can you still do that method with these ones?
yeah, you can.
Okay, let's go ahead and do that.
Okay, so both of them go into 10. So this one goes into 10 2 times, so times 2. And you do the same thing to the top.
Okay.
So 8 times 2 is 16. And then over 10. And then this one, 2 goes into 10 5 times. So times 5. You do the same thing to the top. And then 3 times 5 is 15. So 15 over 10. And you see that this one's greater. So 8/5 is greater than 3/2.
Okay. Have you ever cross-multiplied?
Yeah, you could do that too, I guess.
So how would that work with this problem? So let's take this away quickly so we can just see the original problem again. And we'll just take that out of there for the moment. So how would we solve this by cross-multiplying?
You multiply 2 times 8, and you get 16. And then 5 times 3, you get 15.
There you go. And it still comes out to be the same way, right? Okay, so go ahead and put the symbol in there. So that way, it is a way that you can do it other than finding the denominator the same, right? We can also cross-multiply to do that. Sometimes it's a little bit easier. And the more ways we have, the easier it is sometimes.
Yeah.
All right, so now the option is yours. How would you like to do that one? Decimals, common denominators, or cross-multiply?
This one, I'll just do decimals.
Okay.
So this 3 6, if you simplify it, you get 3 divided by 3 is 1, and then 6 divided by 3 equals 2. So this one's 1/2.
Okay.
And then this side, if you do the same thing, you could do 7 divided by 7, or 7 divided by 7 equals 1, and then 14 divided by 7 equals 2. So both of the fractions are equal to 1/2, so which means they're the same.
Nicely done. Now, you said you wanted to do this one with decimals. So if we had 1/2, what would that be in decimal form?
It'd equal 0.5. And same with this side.
Perfect. So that way we've got all 3 ways. Common denominator, cross-multiply, turn them into decimals. Merrick, nicely done.
Thank you.
Good work. And again, we had a wonderful time over on the Central Coast, as we always do. So perhaps you guys can hook a ride on next year and check it out. Hey, we do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Just a reminder, if you, like Chuck said at the beginning of the program, if you missed school, you need to get caught up on a little something, or you kind of got a pretty good idea of what you're doing, but you just want to verify what you're doing is correct. You're like, I'm pretty sure I've got it, but I just want to make sure before I turn in my homework or I'm getting ready for this test. That's exactly what we're here for. Any age level at all. We've had students as young as 1st and 2nd grade phoning in. We've had juniors and seniors in high school and students attending colleges
sometimes
also calling in, and the occasional adult. Doesn't hurt. Sometimes the adults have phoned in and said, listen, I'm trying to help my student and I'm trying to explain it one way and we're not meshing. Can you help me out with another way to do it?
Sure.
And by all means, we'll help you out with that as well. Right now, though, we're going to go back out live to Castle Elementary and Mary Lou.
We are live at Castle Elementary School, the ACES After School program, and I have another special guest with me today, Emily. How you doing, kiddo?
Good.
And what grade are you in?
4th grade.
So you're also doing fractions. Yes. Emily, what's your favorite thing about Castle?
My favorite thing about Castle is that they, I don't know.
Do you love everything about it?
Yeah.
Okay. All right. Well, let's go ahead. Now, when we were working with Mark, we were talking about adding fractions and making sure they have the same denominator. Correct? Okay, so we got a word problem, right? Here we go. It says, I have 2 candy bars. I ate 3/8 of the candy bars. How much do I have left? Now, with word problems, we need to circle important information, huh? What's the important information that you can circle?
We could circle the 2 and we could circle the 3/8.
Okay. Now, would you say this is an adding problem or a subtracting problem?
Subtracting problem.
Why?
Because it says it says that I ate 3/8.
Very good. Yep. And then it says here, what's the last sentence?
How much do I have left?
That key word right there, how much, right? And the other word is left, tells us, right? Keys us in. Okay, how could you solve this? Instead of using a math problem, is there another way to solve it?
Yes, you could use a picture.
Why don't you show us? So what are you drawing, Emily?
I'm drawing a bar graph. This to represent the candy bars.
Okay. So what are we going to do then once you have your bars?
You're going to put them into 8 sections.
Okay. Let's see. We have 1, 2, 3, 4, 5, 6. Why don't we break that in half? 1, 2, 3, 4, 5, 6, 7. Break one more in half. There we go.
And this one. 2.
6 and 7. I think that'll do it. 1, 2, 3, 4, 5, 6, 7, 8. We got it. Now, why did you want to break them in 8s?
Because the fraction is 3/8.
Okay, I'm going to give you another pen. Okay, different color pen. So what are you going to do next?
You're going to shade in 3 on each box.
Each box or just one? Because we only ate 3 8s.
Yeah, actually 1.
Okay. So does that represent what you ate?
Yep.
Okay. So, can we figure out our answer, how much we have left?
Yes.
All right.
So you count 1, 2, 3, 4, 5. Yeah, 5. And you count, and that's 8.
And that's 8, right?
Yes.
Well, this is 8, so let's write 5 here, right? We have 5 pieces here. And we have 8 pieces over here, right? So what's 5 plus 8?
5 plus 8 equals 13.
Very good. So we have 13. Let's write this. We have 13 out of 8, right? So let's put a fraction bar out of 8. But that's our fraction, right? That's called an improper fraction because the numerator is larger than the denominator. Do we have one whole candy bar here? Yeah.
Yes.
We haven't eaten that, huh? So we still have one whole candy bar, right? So put an equal sign for me right here. And put a 1. That 1 represents this one whole candy bar, right? And then what do we have left over here? How many pieces?
We have 5 pieces left.
5 out of how many total?
8.
8. So write 5 8s next to that for me. There you go. This, we know it's 13 out of 8, is an improper fraction, which is the same thing as saying 1 and
5 8.
5 8. So a picture helps, huh? All right, kiddo, come on, let's go check out what all the other groups, because everybody, all the groups have been solving this differently than you did. So we're going to start with this first group over here. Can you guys tell us what you did?
We drew 2 circles and divided them into 8 parts and shaded in 3. So that left us with 5 8s of a candy bar.
Okay. Now, I know on this one you did 3 8s on both. Did you need to do 3 8s on both or just on one of them?
Oh, just on one.
Just one of them, huh? But see, you did circles instead of bars, huh? Really good. Now over here, you guys decided to do it mathematically, huh? Well, I'm going to help you out real quick, okay? Because you were on the right step. We just forgot to change to the same what? Denominator, huh? Okay, so write 2 over 1 for me. And we're going to change the 1 to an 8. So in order to do that, we have to say 1 times 8, huh? So put it times and an 8. And what's 1 times 8, everybody?
8.
8, okay. Now I want you to times this by 8 as well. So we're going to say 2 times 8.
16.
And that's what?
16.
And put your fraction bar underneath. So write 16. And put your fraction bar underneath that. Now put minus for me. And bring down your 3 8s. Now everybody, what's 16 minus 3?
3.
What's 16 minus 3?
13. Oh, 3.
What is it?
13.
13. So, but our equals. There you go. And write 13. 13 over what?
Oh, 8.
8. We're just going to bring the 8 right over, huh?
Yeah.
And so instead of drawing a picture, we could do this mathematically too, huh?
Yeah.
Simply by finding equivalent fractions, right? And the same denominator. Good job, guys. Good job. And in this group over here, you guys did the same thing, huh? You did the candy bars. You did the squares. And we see that here's 5 and here's your 8, right? Which gave us the same answer. Good job, guys. Good job. So, Emily, what we need to remember, right, again, is we have to have the same denominator.
Yes.
But do we always have to do it with a math problem?
No.
How else can we do this?
We could do it by using pictures.
Very good, absolutely. Then there's lots of different ways, as we saw, to solve a problem, right, guys?
Yes.
Okay, so we got more fractions coming up when we come back. So back to everybody at the studio.
All right, thanks for that, Mary Lou. Well, you know what? We have Gabriel in studio with us right now, and as we were watching that, what was the comment you made about the student's desk?
Oh, it's funny because my name's also Gabriel, and my desk number is also 21.
Right, because as we were looking at the students at Castle, the name tag had Gabriel 21, and he goes, I'm Gabriel and I'm 21 also. So, coincidence right there, huh?
Yeah.
All right, well, you know what? Enough of a coincidence. Back to work, young man. Over to the board. Here we go. Since we have 21 as your lucky number today, I'm going to put 21 in this problem.
All right.
All right, here we go. 4, open parentheses, 2x minus 3 plus x, close parentheses, minus, open parentheses. There's a reason I'm not having a number out there, because I want to see if Gabriel can figure that out.
Okay.
4 plus 2 minus x, close parentheses, and Gabriel, I'll leave it to you. Should we add or subtract 21 at the end of all this? At the end of it all, are we going to add or subtract 21?
At the end of it all, we are going to...
Tick, 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 young man. Add or subtract?
Just pick one.
add, I guess, add.
All right, so add 21 to the end of the whole thing.
Good choice.
There you go.
Good choice. Okay, so let's look at this problem. And remember we were talking about parentheses earlier?
Yeah.
And I said we always want to focus on the stuff in the parentheses first, right?
Yeah.
Let's just attack this piece right here first. Do you have any kind of idea what you want to do with this first set of parentheses? I'll let you hold the pen. And let's talk about it before we put anything on the board.
All right. Well, we should probably simplify. So
Okay.
get rid of the x's probably.
Okay, so we can combine these two x's, can't we?
Yeah, it's
Right.
an x with. I forgot the name. X squared.
Okay, so when I look at this, let's look at it a little carefully. There's no number in front of this x. Right now there isn't.
Yeah.
But can we agree that that's only one x? There's only one of them there?
Yeah.
There's two x's right here,
Yeah.
and there's one x right here. So let's go ahead and put a 1 in front of it really quickly. Go ahead and do that with your pen. So let's just write that 1 in front of there. So anytime that we don't see a number in front of a variable like that, we could put the number in front 1. 1 times x is just 1x. Now, what we have to do is, we're going to combine these two, like you were saying, but this is 2x, and then that says plus 1x. So now think about this, 2x plus 1x. How many x's would we have total if I combined them?
3.
Okay, so let's go back down here and rewrite this problem. I have my 4, so go ahead and copy down the 4, bring it down, and let's just rewrite this problem with that one change.
Can I
parentheses?
I was just thinking about the
Yeah, and now let's, instead of writing 2x and 1x, we're going to write 3x.
Oh.
So if you flip it around, we can use the eraser on it. There you go. And put 3x.
Oh, that was
It's okay. It's hard to use this, huh? Minus 3, don't forget that. And then
yeah.
we'll close parentheses. And let's focus on just this. We won't write the whole problem down yet. Let's focus on this. What have you, in your studies, have you worked on any kind of problems where you have a 4 in front and this is parentheses right here? Do you know what we have to do?
I believe that I'm pretty sure that you multiply 4.
Okay, times this entire quantity.
Yeah.
We have to multiply 4 times this entire quantity. So what I'm looking at is this like rainbow. I'm looking at 4 going to get multiplied by 3x, and 4 is also going to be multiplied, be very careful, a negative 3. So 4 is going to have to be multiplied by that minus 3 as well. So let's go ahead and down below, oops. I don't know if I can undo that here. All right, guys, let me do it one more time. All right, so let's go ahead and do this. 4 times 3x. Go ahead and put the number down there for me.
4 times 3.
What is 4 times 3x? Let's actually just write the number.
Oh.
Yeah, go ahead and erase and then just tell us, what is 4 times 3x?
Okay. Is it 12x?
12x. Okay, so let's go ahead and just erase this and write 12x there. And then we have, so after you copy down 12x, let's go ahead and put our 12x here. And now that we have that, we still have to take this 4 and multiply it by this minus 3. So what's 4 times 3 with the negative in front of it?
Negative 12.
Negative 12. Go ahead and put your minus 12 or negative 12 there as well.
And
All
there we
right,
go.
so we have attacked this piece of the problem.
Oh, no.
We're good right there so far. Now let's focus on our second parentheses. Remember, we always do our parentheses first. So here's this quantity inside, but there's a minus in front. So what do you think? Before we do this problem, what do you notice about this minus?
Well, we're going to be subtracting that.
Okay. From that entire quantity, right?
Yeah.
Okay. So the way that we need to start off by looking at this is saying that minus has to be distributed to everything inside. So I basically are going to take this minus, and I'm going to change this from a positive 4 or a plus 4 to a minus 4.
Yes.
This plus 2 is going to become?
Minus 2.
And this minus x is going to become?
Plus?
The opposite? Yeah, because minus is going to be the opposite. So
Oh,
let's
yeah.
go ahead and just rewrite all of this down here. I keep hitting that screen. But let's just go ahead and rewrite everything down here. Oh, there it is. Thank you. Everything over here, but with a minus being multiplied through. So go ahead and change this from a 4 to a, go down ahead and write it right here next to this. We're going to copy it.
Oh.
Minus 4, and plus 2 is going to become?
Oh,
Let's go ahead and remove that real quick because you had it. Let's look at this really quick. What I'm saying is, we know that this is a 4, and I'm going to say minus 4, and then what is the opposite of positive 2?
Opposite of positive 2 is negative 2.
Negative 2, and then the opposite of minus x is positive x. So the way it's going to be written, and we'll write it right here, we're just going to write minus 4, and now you finish this problem. The opposite of positive 2 is going to be written as
All right.
minus
Minus
2, and then we're going to have minus that, so it's going to be positive x. Good. And let's go ahead and just copy this last piece right there as well, plus 21.
Oh, and everything's 21.
All right, so now, give me an idea. What's your first step, or what are you going to do next? Because you have this whole entire problem here. There's a 12x, there's a positive 1x, and then there's all of these whole numbers like negative 12, negative 4, plus 21.
Are we going to simplify this? Combine
Yeah, we
it?
are. Yeah,
Okay.
we're going to combine all of our like terms. So I see there's an x and an x. There's 12 x's here, and there's
So would I do 13x?
13x. Let's come down here and write our new problem. 13x. Yeah, I like the way you use that to show us we're combining 13x. And now we have a negative 12 and negative 4.
Negative 16.
Perfect. And I have 21 minus 16. So if you want to take some scratch space over here, you can actually do 21 minus 16, or you can do it in your head.
I'll just erase that.
Okay.
All right. All right. Oh, but everyone, I hope everyone understands that.
Yeah, we got you so far. So let's go ahead and now say we're going to combine our negative 16 and our positive 21. So if you want to do that same little line there to show us that result.
All right. Okay, so then we're going to, the positive 21, right?
Mm-hmm.
All right.
Exactly.
And then so we have...
If I have 21, I'm going to take away 16 from that.
Yeah,
Okay.
yeah, I was just about to say that. Which equals 15, wait, no, not 15. Why did I put 15? Wait, I can do that though. So, positive 5.
Very nice. Okay. So what we have now is this positive 5 that's going to be added to this 13x. So let's just go and bring that down to the end of this problem. So we have a 13x
plus positive 5.
plus 5. Now let's just take a look at what we did here. We took this
are we
entire
done?
problem.
Miss anything?
Is there something?
Gabriel, did you miss anything in that list of terms?
We haven't used the negative 2. We have
minus 2.
We have not.
Oh, yeah, you're right. We skipped that problem, didn't we? So let's go ahead and combine this minus 2 and this positive 5.
All right.
Good point.
So I just not yet.
All right. So we had 5, and we need to subtract 2 from that still.
Minus 2. Right there. Which equals. There we go. Positive 3.
Okay. And we're still going to have to combine that to our 13x. So let's go ahead and take our plus 3 and put it over here as well. So we have our 13x plus 3. And we have our answer. Gentlemen?
So nicely done. Now, taking a look at the very beginning of this whole process, let's work on some vocabulary, Gabriel. So, Jesus, at the beginning, what were you guys doing? So, Gabriel, what were you doing at the beginning of the problem? Take a look at where Jesus is pointing at.
We were taking everything in the parentheses and we were simplifying it.
Okay. So we had to start off by simplifying or combining all of our like terms. So
Yes.
we call those like terms, and we're going to combine them, which is what you were thinking when you said simplify, right? Okay.
Yeah.
Now, after we combined them all, we had to deal with this 4 being multiplied by that quantity.
Yeah.
And what do we call that when we multiply the 4 by everything on the inside of that quantity? There's a name for that. it's actually just like it sounds. We're going to distribute the 4 to everything on the inside. So we're going to take this 4, and it's called the distribution. We're going to distribute 4.
Yeah.
Okay, which is multiplying. All right, so a lot of this had to do with simplifying like terms or combining like terms, and then distribution. You saw the negative that had to be distributed also on this problem. Very tricky problem as well on that one.
There you go. Nicely done. So come on over, Gabriel. I just wanted to make sure you had some of that vocabulary down. So when you get into higher grades, when they go over to now we're going to combine like terms, you know what they're talking about.
Yeah.
And when they say use the distributive property, you know how to do it, but just being able to recognize that terminology and the distributive property is an important one also.
Yeah.
You good?
Yeah.
All right. Well, you know what? We do have phone tutors available until 5:30. And do remember, if you're calling from the Central Coast, that phone number is toll-free at 1-866-636-6284. One final time, we're going to go out to Castle Elementary and Mary Lou.
We are back live at Castle Elementary School, the ACES After School program, and I have one more special guest with me today, Christiana. And Christiana, you're also in 4th grade. Yes. What's your favorite thing at Castle?
The field?
The food.
The field.
Oh, the field. I thought you said food. You can tell I'm hungry, and I love talking about food. The field. Why the field?
Because me and my friends could actually walk and talk on the field.
It's pretty big out there, isn't it? All right. So we've been talking fractions today, yes? We've added fractions, we've subtracted fractions, but the biggest thing about it is that we've been talking about equivalent fractions, huh? And we need to understand equivalent fractions to really understand adding and subtracting. So here's a problem behind you. Turn around, kiddo. It says, are a half and 3/6 equivalent? Again, what does that word equivalent mean?
It means it's the same.
Yeah, equal, right? Can we show this in a picture?
Yes.
Okay, why don't you draw me 2 circles? You can use any pen there. And that first circle, what are you going to break it into?
2.
Okay, and what you doing now?
Coloring one of them.
Okay, so this represents 1/2?
Yeah.
Okay, right, 1/2 underneath there for me. Okay, now let's draw the second circle. And Christiana, how many pieces are you going to break that into?
3. Well, 6.
6, right? We'll break it into 3 first. If we break it in, well, there's 4, right? Here, hold on. I'm going to show you a really easy way to break it into 3s. Make a peace sign. You know what a peace sign is? Start here and go to the center. There you go. And then go from here and then bring down. And then you have 3, and now break these in half. Break each one in half. So just do a line in there and do another line here and then one more line there. Okay, how many pieces are you going to shade? There you go. So what do you think? Do you think that this 3/6 and 1/2, do you think they're equal?
No.
Well, let's see. We only have half shaded here, right? And how many? I have 3 out of 6. How many pieces do I have left here?
3.
3, but did you only shade in half though? If I take away this and that, did we actually shade in half of the circle?
Yes.
You did. So actually these are
Equal.
So let's do it mathematically. Ready? Let's think about this. 6 is our common denominator, right? So 2 times what is 6?
12.
No, I'm sorry. 2 times what number is 6? 2 times
3.
is 2 times 3 6?
Yes.
Okay, so if I say 1 times 3, what do you get?
3.
3. Put 3 there. So they are equivalent, huh? So we could show it, Christiana, by 2 ways. Either by drawing a picture or just making an equivalent fraction. So we could do it either way, mathematically or by a picture. Okay, so does everybody have their pens ready?
Yes.
Yes? Here we go. You guys ready for the challenge?
Yes.
Okay, you're going to tell me yes or no. Here it is. Let me write it over here. Is 4 over 5, is that equal to 1/2? Okay, is 4 over 5 equal to 1/2? Go, quickly. First group that has it, raise your hand. Let's see, talk about it. You could do it mathematically, or you could do it with a picture. So what are you guys going to do?
I don't know.
Think about it and talk about it.
We're gonna have to do this, and then we would have to put 4/5 over here and see what we can get to
What do you guys think?
from 1.5 to get to.
Can you do it with a picture? Draw 2 circles. Try it with a picture. Draw 2 circles.
We're doing 4/5.
Well, try to do it with a circle. Draw a circle.
Okay. I have a sticker.
And draw a circle here. Now shade in 1/2 of this circle. Okay. Now break. That's okay. Now make 5 out of this. Do you want to make 5 out of it?
2, 4.
And then just do 1 line. Now shade in how many? 4. Okay. Do you guys have it? What do you guys say? Yes or no?
No.
No?
Isn't equivalent because that's going to multiply this for 5.
Very good. It's not equivalent. Good job. Let's see what this group did. Does those look equivalent?
No.
No, they're not. Very good.
Can I write no?
You guys, yeah, right, no. So you guys, is 4/5 equivalent to 1/2? No. Christiana, get on up here. Well, I want to thank Christiana, and I want to thank Emily and Mark over there, my dancing king, for letting us come today. You guys have absolutely been wonderful. And I want to thank the ACES After School program here at Castle Elementary for allowing us to come on over today. And it's been great, you guys. You have fun?
Yeah.
Yeah?
Yes.
All right. Back to you at the studio.
All right. Hey, Mary Lou, you know what? Keep all those kids close by, because what we're going to do right now is we're going to have Gabriel with his last task of the day. You're going to pull out one of the names from the students that have been doing math problems all day and figure out who's going to see the condors. So go ahead, reach your hand in there. You'll feel a couple of different slips, and you're going to pull out one of those. And we'll find out who the winner is. And who is that?
That is Mark in 4th grade.
All right, so there you go. Congratulations, Mark.
All right, there he is.
Sell 4 tickets to go see the Bakersfield Condors.
4.
There you go.
4 tickets,
Congratulations. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Jefferson Elementary School, home of the Patriots, and today we're all here to... Do the
Good afternoon and welcome to Do the Math. I'm Michael.
I'm Chuck.
And I'm Mary Lou. Need help with your homework tonight? Give us a call. We have tutors here until 5:30. You could call us at Bakersfield at 636-4357, or if you're calling from San Luis Obispo, you can call us toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org, or you can catch us through Facebook, Twitter, Instagram, all that lovely stuff.
All right. Well, nice to have you in studio again, Mary Lou.
Yes.
Because as everyone knows, you're always out and about, and you're the one that we send out to the schools most of the time, and the businesses and things like that. And we've got Devin helping out today. He's out at Jefferson. We'll be hitting up with those guys in a little bit. We do have a very special guest in studio from Singlum Elementary, and you know that basketball, college basketball, is winding down.
Yes, it is.
And the big event is the Final Four.
Yep.
Right.
So do you guys follow any basketball teams you're hoping to see in the Final Four?
Well, UCLA's doing pretty good.
I think they're number 3 right now.
Yeah.
And we'll see how they get divvied up when the 64 teams are announced or whatever. But the reason I bring that up is because we are in our Final Four, our final 4 weeks of the season. So we've only got a few more weeks. So if there's something you need to brush up on before the end of the school year because of the standardized testing and things like that, we've got 4 more weeks, counting this one. So before we get to that and all of the other events of the day, let's first take a look at today's Math in the News. And let me be the first to apologize. It has nothing to do with food today. Okay. Usually you know that I like to say food things for when you're in here and things like that. But when you I think it was last week, you were over at Boss Pizza.
I was at Boss Pizza.
Tack over there. So that was an excellent time
it was
over
wonderful.
there with you guys, and everything turned out well on this end as well. Do you carry a wallet?
Yes, I do.
You have it on you?
Yes, I do.
You don't have to show us, but how many credit cards do you have on you right now?
Credit cards, probably 2 on me right now.
As do I. One is actually my bank card, but I use it as a credit card, and then another credit card. In your purse or whatever you
Just a
carry
bank
around,
card.
just a bank card.
That's it.
Well, you know what? There was an article that I found about a month ago. The man who gets lots of credit. And it starts off with, in your wallet, you probably have a credit card or 2. As we all do. Maybe 4 or 5, 10, a little bit on the high side. 1,500.
Oh, seriously.
Walter Cavanaugh is the man's name. A financial planner until he retired about 15 years ago. He's about 75 now. Holds the record in the category of largest collection of valid credit cards.
Valid, right.
Valid. Okay, they are all current. With 1,497 credit cards at last count. What do you think his credit is worth? The credit line that he's got.
Oh, well, yeah, it's got to be.
Yeah.
Well, we've got it on the board right here, so let's go ahead and take a look at
You
the
figure
screen right
1,000,
now.
at least 1,000 times 1,000. It's got to be
So
at least $1 million.
$1.7 million he's got a line of credit for. So it got started on a bet. In the late 60s, he and a buddy in Santa Clara, California, made a silly bet. The guy who could collect the most credit cards by the end of the year would win dinner. He collected 143. The other guy collected 138.
Wow.
So it's not like you wiped him out or anything or
Yes,
beat him badly.
yeah.
It was 143 to 138. But unlike his friend, Kavanaugh didn't stop.
He got hooked.
He got hooked. So, and they are, like I said, they're all cards from current companies. Now, with that, if we take a look at the screen, he has to fill a 250-foot-long wallet, which is also recognized by Guinness as the world's longest wallet. So this guy...
Got to keep him somewhere, right?
Okay, and he has a near-perfect credit score, okay, because it says, he usually just uses the one and pays it off.
Yeah.
But he has all these other ones that are valid.
So he
Right,
just has a
because
collection
if
there.
you didn't pay it off, the interest would be,
Yeah.
interest on 1,500
Using
credit
all of
cards.
those things.
Yeah.
But as we can take a look at the screen right here, it says that we've got a credit card holder for 90 cards. So I went on Amazon and was looking around. All right, if you want a credit card holder to hold 90 cards, that's going to cost you $16. This guy doesn't have 90 cards, okay? How many holders will he need, and what would the cost be? So, that's the question right there. So we can just take a look at this, and we've already done the math for you and things like that, but that would be a question where you would get some information about Mr. Plastic Fantastic right there. And with the amount of credit cards and the length of the wallet and the cost for a credit card holder, you would need 17 of those 90 card holders. And the wallets, just those holders, will cost you $272.
Wow.
So you're going to spend $272 just to
hold your credit cards.
Your credit cards around. That's today's Math in the News.
So
Mr. Plastic Fantastic.
I wonder how many he has on him at any one time. One at a time, you think, maybe?
Oh, I'm sure he's got the one that he uses and maybe a backup one.
A backup.
You know, but I'm sure they're all kind of in storage someplace and hopefully in a safe, I would imagine.
Yeah.
Anyway, in studio with us right now, we have another. You don't use credit cards yet, do you? No. Well, in studio, we have Morgan. And Morgan, why don't you let everybody know where you go to school and what grade you're in?
I go to Singleham Elementary, and I'm in 5th grade.
That is home of the Lions, if I'm not mistaken, correct?
Correct.
All right. Have you guys learned about credit cards?
Not really.
No, I was going to say, probably not yet. But you know what? We have a great little thing that we do with Kern Schools Federal Credit Union. And sometimes you can see on the program where we do some features with them, and they talk a little bit about credit because before you know it, when you get into junior high and high school, you're probably going to start getting these cards or invitations for these cards to use. You know, come on. At the junior high and the high school level, kids are getting the mail and things about, let's start opening up some credit and things like that. Do you have any idea what a credit card is or what it does?
A credit card is basically a card that has when you swipe it, or if it has a chip on it, you can put it in the machine and it has money on it, basically.
Is it free money?
No.
No. Okay, that's a good thing to understand right there. And so you're in 5th grade, and probably I would say in 6th grade, you'll probably start doing some problems with credit and interest and things like that. And if you don't in your regular classroom, I'm pretty sure, because you're in another program where you get some enrichment work also, right?
Yes.
So you'll probably be doing some of that with your teacher next year, I'm sure of that. Yeah. Anyway, right now we've got a moment to work on. So how about if you head on over to the board, and we're going to have you work out one problem. And let's see. When you came in, I was asking, because the homework packet that you brought in, there's a lot of different things in there. And you said that you're pretty good at dividing. But when I asked you about dividing decimals, you were like, ooh, not so much. All right? So here's what we'll do. I will let you select a 3-digit number. So what 3 digits would you like? What number would you like to do?
325.
All right, go ahead and write that nice and large on the board. And we'll put that, as they say, in the house. All right, so put the division symbol out there. There you go. Mary Lou, you can come up with a single digit between, well, obviously 1 and 9.
Okay. 6.
And we'll put the decimal, instead of to the right, we'll put it to the left of the 6.
There you go.
All right, so you're going to go 325 divided by 0.6. All right, so go ahead, work through it. Explain to Mary Lou how you're going about this, and if you need some help, Mary Lou is right there.
Ready?
Okay. So 6 doesn't go into 3. It goes.
First of all, what we need to do with the decimal point?
Not sure what to do with the decimal point.
Okay, this is our divisor. This is our dividend, our first number, right? Our divisor, we always wanted a whole number. And in order to make this a whole number, I need to move my decimal point over, remember this now? One time. So what I do to this number, I have to do also to the number in the house. Where's the decimal point on this number normally? Is it at the front or is it at the end?
It would be at the front.
Actually, it's at the end because it's a whole number, right? This is your ones, this is your tens, this is your hundreds. So your decimal point is here. So if I moved it once here, do we need to move it once here as well? What we do here, we have to do here. So move your decimal point over one time. And so what do we need to add? If we moved it over, what do we need to add?
Add a 0.
Add a 0 next to that 5. And then we're going to take this decimal point and we're going to pull it straight up to there, okay? Now you can start dividing. Now you're ready.
Okay. So 6 doesn't go into 3, but 6 goes into 32.
How many times?
5 times.
5 times, but let's put this 5, and I'm going to move it for you. Let's see if I can move this. We're going to move it right there, because think of, we need to keep everything lined up nice and neat, right? Okay, keep going.
Okay. It would equal 30, and 32 minus 30 is 2. You would bring the 5 down. Six goes into 25 4 times.
You got it, 4 times.
And it would equal 24. And that would be
1. And then what are we going to bring down?
The 0.
Right.
The 0.
And we'll just need this rounded to the nearest 10.
Okay. So 6 goes into 10 how many times?
1 time.
Okay.
Be 6.
Right. Here.
And
so
7
we're
6
out
is
of
4.
numbers, aren't we? So
Yes.
what do we need to add here? Another what?
0.
0. Add another 0 for me. And let's bring that 0 down. And 6 goes into 40 how many times?
6.
There you go. And that goes on the other side of the decimal, because that 1 should be over the 0, okay?
And that would equal 30.
36?
36, yeah.
What do you notice is happening? Here, let me move this down for you a little bit. Let's see. What are you noticing? What's our difference here? Is it 4 again?
Yes.
It is. So what's going to happen? Do you think we're going to keep repeating with 6 and 6 over and over? We are. We actually are. Because there's a 4, right? And then we have to add another 0. And we got 40 again. And then so we're going to add another 6. So this is going to keep repeating on and on and on. So what we're going to do is put a bar that calls repeating, okay? That tells us in math, hey, this number is going to repeat on and on. So what can I, because Mike said round it to the nearest 10th, what can I round the 6 to? Am I going to keep it at 0.6 or am I going to round it to 0.7?
We're going to round it 0.7.
Okay, write us the final answer here for me. Right over here.
Okay. Wait.
Oh, that's okay. Here. There we go. We'll get rid of it. There. There you go. And that's it. Circle it. Just circle the whole thing for us. Now, the biggest thing to remember is our divisor has to be a what?
Whole.
A whole number, right? And so we got to move the decimal point over, and what we do here, we do also inside the house. Good job. Good job, kiddo. There we go.
Nicely done, ladies. We'll get back to work with you guys in a little bit. Just a reminder, we do have phone tutors available until 5:30, but right now we're going to head out to Jefferson Elementary and Devon.
Thanks a lot. We're here at Jefferson. I'm joined today by Anaya and Diego. And today we're going to talk about fractions. Now, we had a really interesting conversation about fractions before we went live. We talked about, because, Diego, you're a 4th grader. Anaya, you're a 5th grader. And so, there's a lot of gaps with what we know about fractions. And we had a really interesting conversation about how to use language to make sense of fractions before we really taught it. So the way that we started off was we had this problem, just very straightforward with fractions, and I presented this to Diego. And we said 3/4 plus 2/4. And right away, Diego thought about it, and he said 5/8. So can you explain why you said it was 5/8?
Because I thought you had it add the 4 and 4.
So by view of natural pattern, Diego added across in the numerators and got 5, and added across in the denominators to get 8, which is a natural pattern. When we see patterns in math, we want to follow those. And when we add numbers across, when we grow up, when we get older, when we go through school, we add across, right? And so it's only natural to see the denominator and want to add those across. But a funny thing happens when we present the same problem using words instead. So we wrote the same problem, and Diego looked at this and instantly had an aha moment. So Diego, talk a little bit about what happened when we wrote this. We said 3/4, and we actually wrote out the denominator here, fourths, plus 2/4. So Diego, when we did that, what was your aha?
My answer?
Yeah.
5/4.
So
5/4.
So why did the way that you looked at this problem change when we looked at it with words instead?
Because I thought that because I didn't need to add the 4.
Yeah, so when we think of the denominator as a unit, when we add things that are different, we want to make sure that what we're adding is the same thing. So when we looked at fractions in word form, this became a lot easier to add. So yeah, this became 5/4, and then as soon as Diego saw that, he had another aha about adding fractions. What did you notice about adding fractions when we did this?
That you only have to add the numerators, and you don't have to add the denominators.
As long as you have the same denominator, you don't have to add the denominator to add the fractions together. And that's a very powerful thing to understand about fractions, is that once you have the same denominator, you can keep that denominator. Now, I have another problem that we discussed along the same lines. I went to a different fraction. And so Anaya jumped in based off of what she understands, and Diego helped us out too. We said 3/4, and I'm going to kind of change the fraction that we worked around with a little bit. 4/8. And then we had this conversation, okay, well, what happens then when we write that out in words? If we say 3/4 plus 4/8, well, can we add fourths and eighths straight up? No. Anaya said no, because they're different. And the way that I make sense of this, when we add, we do different types of problems, right? We say, like, if I have 3 apples and I have 4 bananas, there's your bell to figure out what's wrong. The answer is 7, we always say. But 7 what? If I have 3 apples and 4 bananas, do I have 7 apples?
No.
Anaya, what do I have 7 of?
7 fruit.
I have 7 fruit. I have 7 fruit. Now, what you did was you found out what both of those had in common, and then changed your unit to reflect that answer. You made these the same thing. When we have 3/4 and 4/8, we want to be able to add the same thing. So is there a way, Anaya, for us to make fourths or eighths the same thing?
You can multiply this by 2.
So she's going to make 3/4 into eighths. So she does that by multiplying both of those by 2. And as Diego had expressed it, do you remember what you call that?
Equivalent fraction.
An equivalent fraction. So we're going to go ahead and turn 3/4 into 6/8. When we do that, now all of a sudden, Diego, this becomes easier to add, right? So here we are. We're talking about 5th grade math here. So we have 6/8 plus 4/8
equals 10/8.
10/8. And we'd write that like this as a fraction, right? A lot of people would expect you to simplify it or turn it into a mixed number. We don't always have to do that in fractions. But getting to this point is very powerful. And Anaya and Diego showed us how powerful language can be when adding fractions. Folks, back to the studio with you. We'll be back a little bit later on.
All right, nicely done out there, Jefferson. Don't forget, 636-4357 is the phone number. Outlying areas of Kern County, as well as San Luis Obispo County, the phone number is toll-free at 1-866-636-6284. Do you have a favorite flavor of ice cream?
Strawberry.
Strawberry. I like strawberry myself. That's a nice one. Anyway, if you call from the Central Coast and we do your math problem live on air, you'll automatically receive yourself some ice cream, perhaps strawberry, from Doc Bernstein's Ice Cream Lab. So if you're ever over on the Central Coast in San Luis Obispo County and you find Doc Bernstein's, go in there and tell them that you were on Do the Math. All right? And they'll be like, whoa, what was going on? Tell us all about it. All right? But you know what? Right now we're going to put you to work. You ready? All right, back over there. So you said that you were comfortable working with fractions. So what we're going to do is we're going to have you multiply some fractions right now. All right, so start over on the left-hand side.
Over here.
And let's go 2/3 times 9/10. We'll start off with something a little easy like that. And explain how you would like to do this. And then if there's another way to do it, or if you're stuck, you've got Chuck right there.
So
When you multiply fractions, what do you do? So that's the first thing, right?
the denominators are not common, so you would have to make them a common denominator.
See, that's the nice thing about multiplication. Most people think multiplication is harder than addition, but in addition you have to find the lowest common denominator, don't you?
Oh, I might be thinking
And in
about
subtraction you do, but in multiplication, nicely, you don't. So when you multiply fractions, you know what you have to do? You've got numerators on top, right? You've got denominators on the bottom. What do you do with those numerators and denominators?
multiply them.
You multiply them. So you can get your answer pretty quick, can't you? Multiply the top, multiply the bottom. Now there's your answer, isn't it? Your answer is 18 over 30, 18/30ths. Except, what's wrong with that answer?
It needs to be simplified.
Right. So we're going to simplify it or reduce it, right? So how do you reduce it?
You divide what is common between 18 and 30, which would be
Sometimes those dots just don't like to come on. Make them a little bigger and they'll show up. There you go.
okay. So
So what goes into both 18 and 30?
6.
6. Okay, can you reduce 3/5? What goes into both 3 and 5? So my first question was, can you reduce 3/5?
I don't think so.
Don't think so, because the only number that goes into 3 and 5 evenly is 1, and that doesn't change anything, does it? So your answer is 3/5. Right? So, good problem, right? Now, Mike said that maybe we could do it another way. You picked 6, didn't you? Why 6?
Because it goes into both 18 and 30.
But doesn't 2 go into both 18 and 30? Couldn't you have divided them both by 2?
Then you would have to divide even more, and it would take much longer, so that is just easier.
These numbers aren't too big, so it wouldn't take you a whole lot longer, but it would take you more steps. You'd get 9 over 30 divided by 2 is 15, and then you'd have to do it again. So you pick 6 because it's not just a common multiple, it's the greatest common multiple, isn't it? It's the biggest number, so that was really nice. So there's your answer, 3/5. Now, do you know another way of doing this problem? Now, everything you did is fine. That's a really good, I mean, you even took the shortcut down and we didn't have to mess around with this. But do you know another way of doing this problem?
No.
What you did was you did the multiplication, got your answer, and reduced it, right? Can you reduce before you multiply? Because it turns out, you said back here, you get your answer by multiplying the numerators and multiplying the denominators. So you can think of, most students don't write this down, but you could think of it as 2 times 9 on top, right? That's where the 18 came from. And 3 times 10 on the bottom. Notice I didn't put the answer, I put the problem, because I get one big fraction, don't I? Can you reduce that fraction
Yes.
Can you think of anything that goes into 2 or 9 and 3 and 10?
And 3 and 10.
What goes into any of those numbers evenly? Well, the 2 and the 3 we said doesn't reduce, and the 9, but how about the 2 and the 10?
Would be
What goes into both 2 and 10?
2.
2, right. So you divided by 6, but here we could divide by 2 and get 1, and divide by 2 and get 5, right? What goes into both 9 and 3?
6. Wait, no, 6 isn't going to 3. 3.
3 goes into 3 once, and 3 goes into into 9 3 times. And so we did the reducing here. And what do you get on top? 1 times 3? 1 times 5?
5.
And there's your 3/5 again. Now, it turns out that most students don't even write this step down. What you'll learn is you can do it right here, right? We said 2 goes into 2 once, 2 goes into 10 5 times, 3 goes into 3 once, and 3 goes into 9 3 times, and there's your answer, isn't it? 3/5. Can you reduce 3/5?
No.
We did all of the reducing up here, didn't we? So there's no reducing in our answer. Great problem. There you go.
All right, nicely done. Now that you've got the hang of it, let's do one more. Oh, no. Turn right around. Get back over there.
Okay.
All right, here we go. Start over on the left again. 9 tenths. 9 over 10 times 15 over 3. Now, I made that number a little larger for you because I don't want you just to go 9 times 15. I want you to see if you can reduce, simplify first before you multiply.
And this is where this comes in handy, right? You could have multiplied 9 times 15 and got an answer, and 10 times 3 and got an answer. The numbers get kind of big, and then it's harder to reduce those big numbers. Can you reduce these numbers?
Yes.
So again, 9 and 10, no, but 9 and 3, what do you do?
And then
So what are you going to divide by?
10, right?
10 goes into 10, but does 10 go into 15?
No, it doesn't.
What else goes into 10? What goes into both? Yeah, 10 and 15, 5, right? 2 and 5, good. Okay, so now let's multiply that. Now you've done all of the reducing. What do you get for an answer? On top?
The 3.
What do you have on top? You got a 3 here and a 3 here, don't you? So when you multiply, what do you get for your numerator?
9.
And what's on the bottom? Change color, that's fancy. So you get 9 halves, right? There's your answer, isn't it? 9 over 2. What's wrong with that answer?
It's supposed to be turned into a mixed number.
Right, because it's an improper fraction. It's top heavy. So how do you change that to a mixed number?
Not good at mixed numbers.
Well, 9 over 2 actually means 9 divided by 2, right? So I know somebody once told me that top-heavy fractions, that's an improper fraction, top-heavy fractions, because they're top-heavy, they fall over. You ever heard this? I'm going to put the 9 down there and divide. 2 goes into 9 how many times?
Into 9. Oh gosh. It would be
2 times what is close to 9? How many 2's in 9?
4.
2 times 4, so 4. No, 4 up here. There's your answer there. And what's left over?
1.
Right, so you got your remainder down here of 1. So you could write that as 4 remainder 1, right? But that remainder, what's left over is, you made this into a whole number, didn't you? What's left over, the remainder, is the fraction. So what are you going to do with that 1? It's 1 what? 1 half. So you're going to get the whole number 4. That was your quotient, right? And what's your fraction? Remainder of 1 over 2. So 9 halves is the same as 4 and a half. There's your problem.
All right, nicely done, Morgan. So a lot of work you're going through right now because you knew about the addition and subtraction of fractions where you were trying to get the common denominator, right? But now, as you get on into the year, you're going to be multiplying and dividing fractions and turning them into mixed numbers. So you knew about the mixed number, right?
Mm-hmm.
And have you done some work with those things yet?
Yes.
A little bit? Well, good. See, now you've got even more, right? So when you go into class and whenever you start doing this, you're going to be a little bit ahead of the game, all right? All right. Hey, we'll be back with more right after this. Today we're at Stein Elementary, home of the Vikings, and today we're here to do the math! All right, well, today we're at Stein Elementary School, home of the Vikings, and with me today I've got Leilani, a 5th grade student. How are you?
Good.
All right, why don't you turn around? Let's take a look at what we're going to be doing here. What do you see first of all up here? What's going on?
I see fractions.
You see fractions. Now, fractions, there are 2 parts. There's a number on top and a number on the bottom. Do you know what those are called?
Numbers?
They are numbers. Indeed, they are. So the bottom number is the
Denominator?
right. And do you know what the top one is?
Numerator?
There you go. All right, let's take a look at the first one over here. What do you think we have to do when you see these set up like this? What are we going to do with these?
We're gonna do
A comparison, right?
Yeah.
Okay, so what is this one? Read this one for me.
5, 6.
There you go. Perfect. And what about that one?
3/4.
There you go. So we want to know which one is greater. Like, is 5, 6 greater than 3/4? Is it less than 3/4? Or is it equal to 3/4? So how would you figure this out so that you could solve this problem?
I would get the pen.
Yeah, go ahead and grab a marker, whatever you want.
And I would do this.
How do you know that?
Because the bottom one is bigger than the other bottom, and the 5 is bigger than the 3.
Well, that's a good way of looking at it. What does that symbol mean anyway?
That the number is bigger.
So you're saying the 5, 6 is greater than 3/4?
Yes.
Okay, and you're going based solely on 6 is bigger than 4.
Mm-hmm.
All right. Do you know how to find least common denominators where we can make the fractions the same on the bottom? Have you worked on that in class yet?
Not yet.
All right. What can 6 and 4 both go into? So think about multiples of 6. What comes after 6? Because 6 times 1 is 6. What's 6 times 2?
12.
There you go. So we can turn this into a 12, right? And 4 will go into 12 also,
Mm-hmm.
right? Now, we said that 6 times 2 is 12. So we do the same thing to the top. So what's 2 times 5?
15.
10. You were right the first time. So go ahead and put a 10 up there. And we go 4 times 3 is 12. So we do the same thing to the top, times 3. So what's 3 times 3?
9.
There you go. So put a 9 up there. So now we have the same denominator. So we have 10 out of 12 and 9 out of 12. So which one has more, 10 or 9?
10.
The 10 does, right? So it's still going to be greater than this one. But that's how we can solve this using least common denominators instead of just thinking, well, that one's bigger, so it must be bigger than that one. So this way we can make sure that it is. All right? So you're correct on that one. Let's take a look at this one. All right. What is that fraction?
8
fifths.
8 fifths.
There you go. Or you can just say 8 over 5. Okay? What about the second one?
3 out of 2.
There you go, 3 out of 2. Okay? So the same thing. Let's figure out, is this one bigger than that one, greater than, less than, or equal to it?
Bigger.
How do you know that?
Because the 5 is bigger than the 2.
Okay, so we're going to go on that again, right? The 5 is bigger than the 2? Okay. I should have put one up here where we're going to mess with you a little bit, but we'll do that later on. All right? So you're saying the 5 is bigger than the 2. Well, let's go ahead and do this same thing with this problem. So what can 5 and 2 go into?
10.
10. All right, so let's go ahead and draw a fraction bar. There you go, and another one over there. And let's put 10 in the bottom. Because we know 5 and 2 will both go into 10. All right? 5 goes into 10 how many times?
2.
2. So we're going to multiply that times 2. So what's 8 times 2?
24.
Almost. That's 8 times 3.
Oh.
So 8 times 2 is going to be 16.
Oh.
All right? So we'll put 16 up there. And how many times will 2 go into 10?
2, 4, 6, 8, 10.
So how many went in?
10. 5.
Oh, 5. There you go. So let's do this. 3 times 5 is?
15.
There you go. So let's put a 15 up on top. So now we can compare them. Which one is greater, 16 tenths or 15 tenths?
16.
There you go. Nicely done. So we'll put that up here also. So we know that 8 fifths is bigger than 3 halves. All right? But this way we can check, because sometimes you're going to see problems where the bottom number might be bigger over here, but it's not always necessarily bigger as far as the fraction is concerned. All right?
Yeah.
Leilani, nice job.
And a big thanks to all of the staff and students out at Stein Elementary and Mr. Hansford, the principal out there, for inviting Do the Math out there. Do a little math in your class. Hey, we do have phone tutors available until 5:30. We've got a lot to get to, so right now we're going to head back out to Jefferson and Devon.
Hey, thanks a lot. Back here at Jefferson. We're here to talk a little bit about equivalent fractions. Ladies, introduce yourselves.
My name is Jalissa. My name is Natalie.
Jalissa and Natalie, they were so excited and they were so nervous. They had all these shakes and wiggles, like almost ready. So like, okay, almost ready. Doing like dancing and doing all this stuff. And now we're on television and they're doing none of it. I'm not going to put you on the spot. Don't worry about having to dance. But what I did ask you to do in anticipation of us coming back is talk a little bit about equivalent fractions. You're into equivalent fractions right now. I was looking at some of the homework and you were asked to prove whether or not 2 sets of fractions were equivalent. And so I kind of laid out a little bit of a challenge. I gave you a set of fractions that were equivalent. So we took that out of the equation. You don't have to worry about finding whether they're equivalent. And my challenge to you was to prove 3 different ways whether or not they were. So let's take a look at the fractions Jalissa and Natalie had to work with. 6/9 equivalent to 2/3. And they were able to generate 3 different models of proving whether or not equivalent fractions did in fact exist. So go ahead and walk us through some of these.
We did crisscross multiplication with 6 times 3 equals 18, and then 9 times 2 is 18, so we knew that they're both the same number, so we knew that it was equivalent. So
what would it look like if these 2 fractions were not equivalent? What would have happened with cross multiplication?
It would have been different numbers.
So these 2 values, 18, they would have been different from each other. So you might have got like 20 here and 18 here, and if that's the case, then we know that they're not equivalent. So that works for a lot of ways, and we'll talk about that in a little bit. But I wanted to go over our go ahead. You guys know the smart words here. So let's talk if they used an area model using a circle here. Yeah, go. Just say it.
Okay, and this one we put 9 nines, and then we color 6 in it, because you can see it said 9 to 6. So we shaded.
I noticed that you got very creative with putting this circle into ninths, right? Because when we see circles, yeah, they get very, very tricky to play around with. When it comes to area models and dividing, because I get what you're saying here. This 6/9 takes up the same amount of space in this circle of the same size as 2/3 does. My advice when it comes to shapes and equivalent fractions is to use regular polygons. And what I mean by that is try to use shapes that have the same angles and the same side lengths. So this is what's called an equilateral triangle. What I would do with this, to make sure that I have 3 pieces of all the same size, start in the middle, and draw a point to each corner. When you do that, all 3 of those pieces end up the same size. Now, could you do that with each of these smaller triangles then?
Yes.
So by doing this, now we have divided this triangle into 9 equal-sized pieces. And if we color in 6 of those, and we do the same thing with 2 out of 3 of those, are they going to fill up the same area of that triangle?
Yeah.
It's a lot easier to break up regular polygons by starting in the middle and drawing a line to each corner. Think about this. The last time you had to divide a circle into 5 pieces. Not smooth, right? So what shape do you think would be easy to divide into 5 pieces?
Maybe.
Well, let's think about this. What shape do we know of has 5 corners that we can connect from the center? Generally, if it has 5 corners, it probably has 5 sides too, right? Mm-hmm. So what do we call a shape that has 5 sides? Maybe if we bring it up here, that would help. A pentagon, right? Mm-hmm. There we go. So we could divide that pentagon very easily into 5 triangles of the same size. All right, so anyway, we use the area model to show. And there was one more model you had. Let's talk a little bit about this.
We had we did almost the same thing as the other one. We did 9 circles and we colored 6 of them, and we did the same thing with the other one. We drew 3 circles and colored 2.
So what's interesting here is for every set of 3 circles, 2 are colored in. Mm-hmm. If we do that over here, with every set of 3 circles, 2 of them are filled in.
Yep.
So we have 2/3, we have 2/3, we have 2/3, and we have 2/3. All those set have the same amounts filled in. That's why 6/9 is equivalent to 2/3. So listen, Natalie. Back to the studio. We'll be back in a bit more.
All right, nicely done. We'll be back out at Jefferson in just a few moments. We do have phone tutors available until 5:30, but right now we're going to go to the phones and a student from Independence High School. Anna, how are you today?
I'm good, and you?
I'm wonderful myself. As soon as you're ready, let's hear the math problem that you're working on.
So, the paper is called Writing Quadratic Equations in Factored Form. And they gave me an equation or a formula, and they want me to find 5 different things.
Okay, so they want, is your answer going to be in factored form, or are you going to put it in standard form? Why don't you give me the information? Because you said in factored form, right?
I'm not sure if it's like, they just give me, what's given is the roots and the point.
Okay, so what are the roots?
The roots are -8, 0.
Okay.
And 2 and 0.
So do you know what the roots of the equation mean if you graph it? No, I don't know, didn't ask you to graph it, but I'm going to use it to help.
Yeah, that's where you point the x's.
Okay, so -8, so that's going to be right there, comma 0, and 2, comma 0. So that's where this quadratic equation, what's the shape of the graph of a quadratic equation or a quadratic function?
It's a parabola.
Parabola. So you know this thing is going to come down and then back up, right?
Yeah.
Well, it might go up and then come back down. Let's see. All right, so what else do you know?
The point is 1 and -9.
The point. So that's a point that's on the graph?
Yeah.
1, comma -9. So 1, comma -9, that's going to be right here. Okay?
Okay.
And what do they want you to find?
They want me to find A.
Find A. Now, A is, in your function, it should be, let's see, y equals ax² plus bx plus c. Is that right?
Yes.
And a is the coefficient of the x squared? Okay.
Yes.
All right, so what do you have to find? Find a? So how are we going to find a?
The equation, direction of opening, axis of symmetry, minimum, maximum, and the vertex.
Wow, direction. What was the other thing? The axis of symmetry?
Symmetry.
Axis of symmetry.
The
Okay.
minimum and the maximum, or the vertex.
So the vertex, we know the vertex is either going to be the highest point or the lowest point, right? It's either going to be the maximum or the minimum. All right, so what are we going to do in this problem? Okay, we're going to look at this and we're going to do it using the factored form, right? If these are the roots, then what are the factors? Do you know? Let me get rid of some of this so we have some room to work. So you know that this is going to be 2 factors, okay, multiplied together to give you 0. But there's an a in there, isn't there? So it might look something like this. Okay?
Okay.
So if it crosses at -8 and 2, isn't it going to be x plus 8 for one of your factors? And the other factor is going to be x minus 2. Is that right?
Yeah.
Okay. So you know that this factor x plus 8 and this factor x minus 2, when they multiply together, they have to be 0, but there's an a in there, and that's what they want you to find, don't they? So do you know how you're going to do that?
No. Okay.
Well, let's see. Let's see if we can find out some of the other stuff. You said you wanted the axis of symmetry and the vertex. Isn't the axis of symmetry right between these 2 points?
Yeah.
So your axis of symmetry is going to be right through the middle of this, isn't it? So your axis of symmetry is this line. What's the equation of this line? Do you know?
No.
Well, let's see. It's exactly halfway between -8 and 2. If you add those together, -8 plus 2 and divide by 2, that's -6 over 2. So this is the point -3 right here. And so your equation is, this line is x equals -3. Okay?
Okay.
And the nice thing about the axis of symmetry is that's where the vertex is, isn't it? It's somewhere on this line. Well, it looks like it's going to come down like this. Let me see if I can do this in red. My graph isn't big enough because this graph looks like it's going to come down like this, go way down here below, and then come way back up like this. See how your parabola looks?
Yeah.
It's going to come down here. Vertex is going to be way down here somewhere. And so I know that my vertex is going to be on the bottom, isn't it?
Yeah.
So the vertex is a minimum, isn't it? Let me write this over here. Okay, so how do we find A? How do we find A?
You plug in.
Well, let's see. What if I did this? What if I multiplied these out? Was that going to work? Can we multiply using FOIL?
Yes.
Okay, what do we get? X squared minus 2x plus 8x minus 16, is that right?
Yeah.
So it looks like x squared plus 6x minus 16 times a equals 0, is that right?
And we'll give you guys a minute to get as far as you can.
Okay. So let's see. We know that the point 1 comma -9 is on this graph, don't we?
You got it.
So that point is going to work in that equation, isn't it?
Yes.
So if I put, and this is equal to y, isn't it? Now I use that to find my roots, but if I put it in here, if I put that point in here, I should be able to find what a is. So let's see if we can do that. and we might have to finish this after. Let's see if we can find this. If I put in 1 comma negative 9 for, let's see, that's nice. X is 1. 1 squared plus 6 times 1 minus 16 times A equals negative 9. Do you think we can solve for A?
Yes.
Let's see, what do we get? 1 plus 6 minus 16 is 7 is negative 8. Is that right?
7 minus 16.
7 minus 16 is negative 9, right?
Right.
So A times negative 9 equals negative 9. So that looks like A equals 1, doesn't it?
Yep.
Looks like A equals 1. So there's your first answer. See what I did?
Yeah.
I took that and I put the point that was on the graph into that equation, and I got A equals negative 1. So it looks like x squared plus 6x minus 16 is your equation. And how do I find the vertex? Well, I know the vertex x is going to be negative 3. So what I'm going to do, and this might be the last thing we do, if I put negative 3 in for x.
And you've got a couple of seconds, and we may finish this up later.
Okay, and then just solve for y. That's going to be 9 minus 18 minus 16. So that's going to be 9 minus 34, which must be
negative 25.
Negative 25. So you have to go way down here, negative 25. So your vertex is at negative 3 comma negative 25. You see where I got that?
Yeah.
I put that point into your equation, and I think we answered all your questions.
Yeah, and if you need some more help, Anna, by all means, give us a call back, because that was such a great problem.
Wow, it was.
We're going to send a free Boss Pizza out your way. So congratulations on that, and put all the toppings on there you like. Hey, you know what? We've got time. One more time. We'll head on out to Jefferson and Devon.
Thanks a lot. Back here at Jefferson with Lukai, and all of our work has been about the concepts of fractions today. And when we talked about 5th grade math with the way that students have been representing solutions, what we came across is something that you generally start to see around 8th grade or algebra in the high school level. It's called the rule of 4. Could you go ahead and kind of explain the idea behind the rule of 4 for us before we get into it?
So the rule of 4 is we have 4 ways to solve like a fraction or so. And so what we would use, the first one is number line, and then area model. And then we would use equivalent fractions, and then we would add like a half or 2/3 or anything like that.
Or some sort of friendly fraction.
Yeah.
So the idea behind the rule of 4 is that you have 4 different tools that you can use to make sense of what a problem really represents. Generally, in high school, that means represent with words, with a table, with a graph, and then with an equation. But here in 5th grade, when we're talking about fractions and how to play around with them and represent them, we're using this setup. And you can use 4 of anything to show what something represents. And in 5th grade in particular, you really need all those tools. Because in 5th grade, they expect that you'll be able to understand and use fractions of any denominator. And so that's exactly what we're going to do here. We're going to go ahead, and I'm going to ask you to represent a fraction with a very uncommon or unfriendly denominator. Are you ready? So let's go ahead and make sense of 5/14. 5/14. Now, 5/14 is a fraction that is already simplified. So, how could we start representing this? And do we necessarily have to start in one box, or do we get to choose which box we start with?
We can start with whatever box.
So, Luca, I'm going to go ahead and have you start running the show on how to make sense of 5/14.
So, first, what we would do on number line is we would make a line, and we would make this.
So I'll go ahead and explain what Luca is. Go ahead.
And then we would make an even line, which would be 7, and then we would go another one like this, There we go.
So Lukai is making using benchmark fractions to split this number line into 14 equal-sized parts, and he starts off by dividing that number line into 7/14 each. And so 1/2 is equivalent to 7/14. It's what we call a benchmark fraction. It's a friendly point we use to start off from. So he's using his spatial reasoning to make sure that he has all the right amounts of pieces to be able to truly represent as accurately as he can what 5/14 would look like on a number line from 0 to 1.
So I got 14 right now.
Okay.
I got spaces, and I would go 1, 14, 2, 14, 3, 14, 4, 14, 5, 14.
So on a number line from 0 to 1, we've identified, ultimately we just want to find 5/14. That 5/14 is going to be right there. Hey, very quickly, Lukai, could you show us another one of these setups here? So which one do you want to show us? Area model, equivalent fractions. Let's show what this looks like with an area model.
Rectangle.
Okay.
And then what I would do is I would go 13 lines.
So you're splitting a rectangle up the same way you're splitting a number line up. But I'm going to challenge you and ask that we divide this up. I'm going to ask you to hold up right there, okay? I'm going to ask, is it okay with an area model if we work with an array? So instead of a rectangle that's 14 long, could we do 2 rows of 7 each?
Yes.
And so how would we fill that in to represent 5/14?
So we would color in, this is 7, right?
Yes.
Okay, so we color in 5.
So he's going to color in 5, and it really doesn't matter which 5 he can color in as long as we represent 5 out of 14 equal-sized area pieces are colored in. Hey, we're going to keep working on this, but we do want to make sure we bring all of our guests in that helped us out this afternoon. Again, a wonderful afternoon of math here at Jefferson Elementary with all of our Patriots 4th through 5th grade after-school program. Thank you so much for joining us. It's been another great afternoon.
All right, well, you know what? Devin, keep those kids handy because Morgan right now is going to select the student that's going to see the condors. So there's all of those names in there. And who'd you pull out of there?
Lukai.
Lukai? So there you go, 5th grade student at Jefferson. So congratulations to Lukai. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.